is osmotic pressure. Before osmotic pressure, there is a term semi-permeable membrane. What is semi-permeable membrane? The membrane which allows only the solvent molecules to pass through it but prevent the passage of the solute particles is called semi-permeable membrane. The semi-permeable membrane has tiny holes or submicroscopic pores which allows the smaller solvent molecules to pass through it but prevent or hinder the passage of the larger solute particles. Okay, so semi-permeable membrane only allows the solvent molecules to pass through it. For why this is called semi-permeable membrane. Example: your parchment membrane, pig bladders. These are the two natural semi-permeable membrane. Along with there is cellulose acetate, which also can act as semi-permeable membrane, but it is synthetic. The semi-permeable membrane only allows the solvent molecules to pass through it but prevent the passage of the solute particles. Okay, generally in a solution, the solute particles have a larger size as compared to the solvent molecules. Next, suppose you take this is solution, this is pure solvent, and this is SPM, semi-permeable membrane. Okay, then if the solution is separated from the solvent by one semi-permeable membrane, then it has been seen that the solvent molecules flow into the solution side from the solvent side through SPM spontaneously. So that spontaneous flow of solvent molecules into the solution side from pure solvent side through semi-permeable membrane is called osmosis. Osmosis is a spontaneous process in which the solvent molecules enter into the solution side through the SPM, that is semi-permeable membrane. And in order to stop osmosis, we have to apply one external pressure on solution side. So that minimum external pressure which is applied on solution side to prevent the osmosis process is called osmotic pressure, which is denoted by pi. So what is osmotic pressure? It is the minimum external pressure applied on solution side to prevent osmosis. Okay, so osmotic pressure means it is the pressure applied on solution side. Why we applied the minimum pressure on solution side? To prevent the osmosis process. Okay, and if we apply the external pressure, suppose this is linked with a piston to apply the external pressure. Okay, and if the external pressure is greater than that of pi the osmotic pressure, which is the minimum pressure applied on solution side to prevent osmosis. If the external pressure is greater than that of the osmotic pressure, then the process will be reversed. That is, the solvent molecules will flow from solution into pure solvent side through the SPM. That is called a reverse osmosis. So there are three terms: osmosis, osmotic pressure, reverse osmosis. What is osmosis? It is the spontaneous flow of solvent molecules into solution side from pure solvent through SPM. What is osmotic pressure, which is denoted by pi? It is the minimum external pressure which is applied on solution side to prevent osmosis. What is reverse osmosis? It is the process of the flow of solvent molecules from a solution into pure solvent side through SPM is called reverse osmosis. When reverse osmosis occurs at this condition, when the external pressure is greater than that of the osmotic pressure, then reverse osmosis occurs. What is the usefulness of reverse osmosis? Reverse osmosis is used in desalination of seawater. That is, to separate the salts from seawater, we can apply the reverse osmosis process. In this side, we take the seawater, which is a solution. In this side, we will take the pure water, which is the pure solvent. And when high pressure is applied, which exceeds the osmotic pressure, then the solvent molecules will flow away from the solution, by which your concentration of the solution increases, which again evaporates to get the solute particles, which is NaCl. So for desalination of seawater, reverse osmosis process is applicable, and osmotic pressure is directly proportional to concentration of a solution. Osmotic pressure is directly proportional to temperature. Okay, with increase in temperature, more external pressure is required to stop the osmosis process. And if higher concentrated solution is taken, then more number of solvent molecules will enter into this higher concentrated solution. To stop that, higher external pressure must be applicable, which is the higher osmotic pressure. So from this we can write pi is proportional to Ct, okay, or pi equal to R into Ct. R is the proportionality constant, which is the universal gas constant. So we get pi equal to CRT. This is the expression for the qualitative property osmotic pressure. What is C? C is the concentration in molarity, that is pi equal to N2 by V RT. C is the N2 by V. Concentration means it is the number of moles of solute present per unit volume in liter, or pi equal to W2 by M2 RT by V. So this is the expression for qualitative properties. Pi, which is osmotic pressure, W2 RT by M2 V. What is V? V is the volume of a solution in liter. What is W2? W2 is the amount of a solute in gram. Like that, M2 molecular mass of a solute. So this expression is used to calculate the osmotic pressure of the solution. And from this we can calculate M2 molecular mass of solute, which is W2 RT by pi V. So the usefulness of qualitative property is to determine M2 molecular mass of a solute. Okay. So by using four qualitative properties like relative lowering in vapor pressure, elevation in boiling point, depression in freezing point, osmotic pressure, we can calculate the molecular mass of the solute like macromolecules, like biomolecules, proteins, enzymes or polymers, etc. And out of these four, it is the osmotic pressure which is the best method to predict or to calculate the molecular mass of the proteins or biomolecules. So why osmotic pressure is most preferable to calculate the molecular mass of a solid? Because osmotic pressure is measured at room temperature, that is 25 degrees Celsius. Okay, and at room temperature the proteins are more stable as compared to the freezing temperature or boiling temperature. So as osmotic pressure is generally measured at room temperature, so it is most preferable to predict the molecular mass of the proteins. And again, osmotic pressure is related with the molarity of the solution, but the previous one, they are related with the mole fraction of the solute or the molality of the solution. The osmotic pressure is the only one qualitative property which is related with the molarity, that is number of moles of solute present per liter of solution. And the value of osmotic pressure is large for very dilute solution. If you take very dilute solution, then the elevation in boiling point is very small, the depression in freezing point value is also very small, but osmotic pressure value is larger for very dilute solution, and larger value is easier to study than that of very smaller value. The three regimes are responsible for the preference of the osmotic pressure. One is osmotic pressure is measured at room temperature. Second one is osmotic pressure is related to molarity. Third one is osmotic pressure has higher value for very dilute solution. Okay, and next part is application of osmosis. There are large number of application of osmosis, out of which we discuss here three applications. Number one, the saline water has the concentration of NaCl 0.59 mass to volume percentage. In normal saline water, the concentration of a sodium chloride solution is 0.59% mass to volume. Okay, and for that, if the blood cells is wrongly kept in a solution of higher concentration or lower concentration to that of the blood cell fluid concentration, which is 0.59%. So this is the blood cell and this is the fluid inside the blood cell, which has a concentration 0.59% mass to volume. And if we kept the solution, if we kept the blood cell in a solution of a concentration less than 0.59% mass to volume, then what happens? It is less than 0.59% means less concentrated solution. It is more concentrated solution. This membrane of the blood cells acts as semi-permeable membrane by which the solvent molecules, that is water molecules, will flow from the blood cells into the solution, from higher concentrated solution into lower concentrated solution, by which what happens? The blood cells shrink or shrivel. Here the blood cell shrink or shrivel. Okay, and if the blood cell is kept in a solution of a concentration more than 0.59%, then what happens? Then this is 0.59%, this is more than 0.59%, this is more concentrated solution, this is less concentrated solution. So the solvent molecules will enter from the solution into the blood cells, by which here the blood cells swells and finally burst. So the normal saline water must have the concentration of NaCl 0.59% because in the fluids of the blood cells the concentration is 0.59% mass to volume. Okay. Second one is for preservation of a meat, salt is used. Okay, for preservation of a meat we use salt as a food preservative. What happens when meat is kept in a salty solution? Then osmosis occurs, that is due to osmosis the water molecules will flow from the body of bacteria into the salty solution, by which the bacteria shrink or shrivel and dies, by which the meat will be preserved. So due to osmosis, salt is used as food preservative for the meat. Third one is due to osmosis, if you take more salty foods or more salt, then those salt particles are kept in the tissue cells, by which the water retention capacity of the tissue cells increases due to osmosis. So if you take salty foods or more salt, then you swell. Why swelling occurs? By the people who take more salt or salty foods, swelling occurs due to osmosis. The water retention capacity of the tissue cells increases, by which people becomes more fat, and that disease is called edema.